Okay, in Lab 8, we want to use the Spark streaming API to do some, to process streaming data. In the first part of today's lab, we go through two examples from the Spark, the definitive guidebook. And in the second part of this lab, uh, we try to process some data from Twitter. Uh, Let's start with the first section. In the first section, we want to process a data set, including retail data about purchases. If you want to run this lab on Jupyter Notebook, please run this script to create a Spark session. Um, The dataset is available on the head node of cluster at this path. If you look at the directory on the head node of the cluster, you can see around 300 files. In these files, you can see some information about the purchases in this sample retail site. So we first load whole data set in a static data frame. We call this data set static because we load whole data in the data frame. Here we create a representation of data, and we store this representation in this static schema. So we will use this representation later on to stream the data. First, we want to we want to do some batch processing stuff on the data. So we first use this static data frame, including whole data, to do some processing. As you can see here, the first script list customer ID and the fund they have spent on some items and they bought from this retailer. So as you can see here, customer this script return customer ID and the money spent in the retailer by this customer and the invoice date. So the output of this script will be a table or a data frame including three features: customer ID, total cost, and the date, the purchase date. The next is query group by the data based on the customer ID, and then sum the total cost spent by this customer ID. So here we have all cost spent by this customer ID separately, but with this query, we group by all the transactions based using this customer ID feature. In the next query, we define a window. So if you remember in the lecture, we had a 10-minute window. Here we define a window over invoice date. This is the window. And we group by the transactions based on this window.
Excuse me, sir.
Yeah.
Why are you introducing the column? You imported the COL in the group by. So in the group by function, you have used the column. In the window function, you use the column.
Because this is a column in the data frame, and when we want to refer to a column here, we should this is the syntax of Spark. So this is a column in data frame, so we want to refer to this data frame, so we should use this term column to
Okay.
refer to that column. So invoice date is a feature, is a column in the data frame, in the static data frame here. So we group by the data based on this window. So we just, like here, the data is group. Anyway, the data somehow, group by uh, windows. It's not a kind of real group by in this example. We didn't apply any group by here. But anyway, as you can see here, we have some uh, windows. So if you group by over windows, so these windows are grouped together. And then we obtain the total cost for each window. So if, I don't know, for instance, here we have two windows, and suppose they are total cost. So if we group by these two together, so we have this, and the total cost is 4. Or for instance, in this example, suppose we have these two windows, and suppose they are total cost. So for the first window, the total cost is equal to 6, and for this window, the total cost is equal to 2. So here we group by based on this window and then obtain the total cost here. Then we want to extend our group by. In the next query, we want to group by based on this window and customer ID. So we group by based on 2 columns and then obtain total cost. So this query returns total cost per each customer and in this window. All these queries are applied to the static data. So it's a kind of a batch processing. Because we give whole data to the system to get processed. Now we want to apply this query. Sorry. Now we want to apply the queries we performed on the static data on the streaming data. So first, we should create a streaming data frame. A streaming data frame is something like this. As you can see here, we have an input stream, and this is a kind of input stream. Or sorry, this is a kind of input data frame. So here we create this streaming data frame. As you can see here, we use this static representations which is created here. So this is a representation of a static data. So we use this static representation to create a streaming data frame. Here we have some options. Max finds per trigger. If you remember, in this example, we trigger the computation to compute output every 5 minutes. And in this step, we process the input data. So here we received input data, input stream data, and we process it, and we update the output. After a while, we have another set of outputs, and then we trigger a computation to compute the data and update the output. So as you can see here, by arriving a new data, we trigger computation to recompute the query and update the output text, the output table. So here, trigger happens in this example. Triggers happens when new file arrive in the system. So in this data set, we have 300 files. One file after another file arrive in the server. So once a new file arrives in the server, a trigger, it happens. So this trigger get the data, process the data, and update the output. So after processing the current file, we have some more files in the directory. So they are streamed to the server one after another. Here we determine the maximum number of files should be read at each time. So in this example, we set the maximum number of files per trigger equal to 1. It means that when you start the processing task, one file is streamed to the server, and this file is computed and processed. After that, only one file, which is the next file, come to the server and is processed. Next file, next file, next file. If here we set the maximum files per trigger to, I don't know, for instance, 5. Each time, five files are streamed to the server. So in triggers, somehow apply computations on the data, and this option max files per trigger determines the maximum number which are streamed to the server per trigger. So we start the computation, one file is streamed in this example. After processing this data, the next file is coming to the server. And after that, the third file, fourth file, and so on and so forth. But if we here put 5, the first time we give 5 files to the system. After that, the next group of 5 files arrive in the server, so on and so forth. Okay, this is the stream which we are going to apply on the data. So I put together all those streams, and this is the final streams, the final query we have. Here, I applied the queries one by one. So first I grouped by, then I grouped by windows, and after that I obtained this sum. So if I put all those queries together, we can, like SQL. In SQL, you can you can split a big query into some subqueries and run the subqueries one after another. Here, in the first example, we executed the queries one after another. So we splitted these long queries into some subqueries and executed these subqueries one after another. But in this here, I have put all these queries together. So this query here performs exactly the same operation we did earlier. So this is the query. But this query doesn't do anything because it's a query, it's a command. If we want to produce the output and if we want to start the stream processing, we have to issue an action, because you know that in Spark, the queries processed after issuing an action. So here I define an action which is write stream. Write stream create a table named customer purchases, and the output of this query is gradually added to this table. So if you look at this example, here we have some table, here we have a table. So this is the output table. In this example, if you look, we have this output table. So this is the output table, and the output of this query is streamed out here. Okay, so when you run this query, the files one after another arrive in the server and get processed. You can run this command several times to observe how the output data is updated over time. So you should first start the process and then run this query several times to look at the data in this table. And you will see that this data is this table, the data in this table is updated over time. Okay, here we have another option in this action. We have another option, output mode. Output mode determines how new outputs interact with previously computed outputs. As you can see here, over time, input data arrive in the server. This output mode option determines how new output calculated based on this new data can be added to this table. So here we have a table and we have some new data. After processing this data, we should determine how this data we already have should be updated based on this new data. There are different output modes: append, update, complete, which are listed here. Append means that the new output can be added to the current output. So, for instance, here in append, we append the new data here. But in complete mode, which is selected here, we recompute the output based on the current output and new output. So we have this current output and we obtain some new output. Then we recompute or we apply the query on this table and the new output to obtain the result table. Okay, so this is the first output. If you want to stop the streaming processing, so you should issue this command. After that, we have one more example. So this example, you can find this example from the Spark, the definitive book. So the definitive guidebook. Uh, in this example, you have a set of physical activities of users of mobile phones. So you want to apply some queries on the user's activity of mobile phones. So there is nothing new in this uh, uh, second example. I have explained all these commands and queries in the first example. Okay, as I mentioned earlier, in the second part of today's lab, we want to process data from Twitter. In the first step, we have to stream tweets from Twitter. To do that, we should use this script, as we can see here. Using this script, we can extract or we can pull out tweets from Twitter, and using this script, we store every 10 tweets in a file. So if we run this script, 10 tweets mentioning Python in their content are extracted from Twitter and stored in a file. After that, a new file is created, and the next 10 tweets containing or mentioning Python in their text are extracted and stored in the second file. And in the same manner, more and more tweets are extracted and read from Twitter and stored in a file. Before running this script, you are supposed to do two tasks. The first one is to create a developer account in Twitter. So here, if you Google developer account in Twitter, this is a link. So if you apply for a developer account, you can just apply for the account, and then you will see this dashboard. In your dashboard, you should create a new project or app, and then I have created a project, as you can see here. So here, after you create your account, your developer account, so you can create an app. So here I create app. So I select a given name for this test app in lab. So this is my application API, and here you have some tokens. So based on the values you get here, you should fill in these four, you should set the value of these four variables. So you should create your developer account. After that, you should create an app, and then based on the values given here, you can set these four values. Then here we have a directory. As I mentioned earlier, every 10 tweets are stored in a file. So here you should set a directory. In this directory, the streamed data are stored. So you should create a directory in your home directory, and here you should put its path. I don't know, for instance, the directory can be /home /your student ID /Twitter stream. So you should create this Twitter stream directory in your home directory. And then you can run this script to stream tweets mentioning Python in the content. So this is the script to extract data from Twitter. If you want to, I don't know, extract tweets mentioning, I don't know, Spark, you should update, you should replace this Python here with Spark, or any other word or term you want, you can use here.
If you
After that,
hello.
okay, let me finish this
Okay.
part, and then you can ask your question. So like before, after that, we create a scheme using the data. We have a string, and then we run some queries on the data. For instance, this query display the content or the text content of tweets. So like previous part, you first create the query, and then you start an action on the data. As you can see here, the output mode in this query is append, because you just append new tweets to the previous output. Or this query gives you some statistics about tweets. So you can just run this command to obtain the summary of statistics in the data you have collected. So this is the second part of today's lab, and I think you can use this script to extract data from Twitter in your project.